Hello, this is Dr. San Abdullah with the course Deep Reinforcement Learning. And the video lecture which we are covering today is the introduction. And the introduction consists of three video lectures, which is 1A, 1B, and 1C. So today we will be covering the lecture 1A of the introduction. And the learning management system we'll be using, which is easymcq.com/goget. So let's go ahead, move ahead. So this is the learning management system and it has many wonderful features. And you can access this learning management system by using the URL in the green. And you can view the videos about this learning management system for the maximum utility by following the URL given in the blue. Now there are 6 videos which explain the features of this learning management system. And those features have been developed by input from students like you, users like you. So it allows very powerful full text search, advanced and basic search throughout the content of this course and other courses which are available here. And any students which have any visual disability, they can change the interface as per the font, the size, the color, the line spacing, and so on. And the text and the contents are optimized. They have diagrams, they have a hierarchy, and you can track your progress so that you know which subject you covered, which topic within that subject, and which question and answers which you covered. And of course, you can assess your performance, your learning, your knowledge accumulation by using the online testing system, which provides the details and your highlights, your weaknesses also. So the approach in this course and in other courses available at easymcq.com is a combination of the Q&A approach and the traditional slides based approach. So the slides based approach is not interactive and it is not thought provoking, it is not very engaging. So those features are included, and the traditional approach has details which are included in this approach. So basically what we do is a blending or a blended learning approach for your benefit. So what topics are covered in this course? This is the list of topics, and we are at the first topic, which is introduction. So which consists of 15 questions and answers. Now these questions and answers are basically concepts, but since we are following a Q&A based approach, therefore these questions and answers are basically the topics, the subtopics, and the concepts. So what is covered in these 15 questions and answers is shown in front of you, and you can see the screen. So this is 1A, which is shown in yellow, which is like a basic concept, and then is in green, which is like of medium complexity, 1B, and then is the 1C, which is of slightly higher level of complexity. So now we move on to the details of that learning management system, and we will go through each of those concepts for your benefit. So we start with the first Q&A. What is the relationship between AI and deep learning? So when we click on this, we see that these are the bullets, and we'll be talking about the conceptual hierarchy which is visible in this diagram. And this hierarchy, then we'll move on to how technology has evolved, and this is all data driven. So the dependency on the data, the complexity of the models, right? Okay, which are modeling the intelligence and the application scope. So first look at the hierarchy. So I zoom in. So basically what we have here is we can see that AI is a broad field. Okay, and what we are trying to do is to simulate intelligence or simulate intelligent behavior. Now this can consist of rule based systems, but the rule based systems have their own limitations, right? Because you need to update the rules, and rules cannot cover everything. So that is not true artificial intelligence. So we can see that we have artificial intelligence, and then we have machine learning. Okay, and then within machine learning we have neural networks. So we have multiple layers. Okay, and then we have deep learning. So with neural networks, okay, the patterns are learned, right? But that involves human intervention. But in deep learning, the patterns are learned automatically. So it is specialized, and this is just data driven technique within the larger domain of artificial intelligence. All right, so let's look at how and what was the impact of technology. Now, when I took the course in, there's a long time ago when I took a course in artificial intelligence, and it was not as popular as it is today. So at that time, it originated with symbolical reasoning. and logic based systems, which we will cover not in this course but in the AI course. And over the period of time, it involved or evolved into machine learning. Okay, so it evolved into machine learning, and then from machine learning, it evolved into deep learning. Okay, through the power of neural networks. And of course, don't forget the GPU acceleration, the graphical processing unit, which we will cover in this topic also. So deep learning represents the latest advancements, okay, which could not have been possible without the processing power. And not only the latest advancement, but also improved accuracy and performance, okay. And it helps in speech and image recognition. These are the applications. So what is meant by data dependency? Okay, this is I am talking about data dependency. So traditional AI methods can work with smaller and structured data sets using predefined rules or features, but that have limited application. Deep learning models, on the other hand, require large volumes of labeled data, okay, and of course processing power also, to learn effectively. Now the performance significantly improves, okay, the quality with more data. So that makes them ideal for big data environments, but less suited for tasks with limited data sets. Okay. So remember one thing, that one has to have high quality data. So that's a data driven domain. High quality means that it should not be skewed in a certain way, it should not be biased, it should be clean. We'll talk about it. Okay. And then is the model complexity. Model complexity, what it means is that AI models can be very simple. Okay. It can be as simple as the if then rules, which I mentioned, right? And of course, they can be moderately complex algorithms also. However, deep learning involves highly complex architectures. Why? Because there are millions of parameters, where those parameters across multiple layers. We'll talk more about it. So what this does, it enables them to model complex patterns in unstructured data, and also makes them computationally intensive, okay, and of course hard to debug. And finally is the application scope. So AI is currently used in broad areas, which includes reasoning, which includes robotics, which includes planning. And deep learning excels in tasks like image recognition, natural language processing, autonomous driving also. Okay. However, it is less effective in applications that require logical reasoning, because reasoning is at a higher level as compared to matching audio or images. And of course, it is not very good at explainability, okay, or working with limited data or domain specific rules. So it has a certain application domain, deep learning. Okay. Now let me clear this. So all the details which I've mentioned are here. Here are all the details which I would suggest that you read all of this. All right. All is there. And if you are interested in more, which you should be, here are the references. Right. So there's a lot of content, there's a lot of material to read. And then of course is a textbook also available. All right. So let's move on to the next Q&A. What is the relationship between artificial neural networks and deep learning? All right. So this basically diagram, this kind of explains, okay, what I've just what we'll be covering. So artificial neural networks basically are used as the foundation. Okay. And what is meant by foundation? They are the basic building blocks of deep learning. What happens is that deep learning extends artificial neural networks by adding more layers. So we have this artificial neural networks and we have deep learning, and more layers are added. But this is just the tip of the iceberg. Adding more layers doesn't automatically makes deep learning. There's much more to it. That's what this course is. And when these more layers are added, that adds more complexity, of course. Now what it provides is that it enables better abstraction and better representational learning, while still maintaining or still relying or replicating the core, okay, principles of interconnected neurons, okay, and weight based learnings. There is a weight associated with this interconnected network. That weight is the learning, okay, that is the learning. Now, other point which is here is the depth distinction. So as you can see in this diagram, that ANNs typically have one or two hidden layers. Okay, this red is the hidden layer. So we can see that there is a single hidden layer for an artificial neural network, but there are multiple hidden layers. There can be hundreds, there can be thousands of hidden layers in a deep learning network. Okay, that's one of the reasons why they are called deep. So what it helps, that it allows them to capture higher level features, okay, and perform hierarchical learning, which we will discuss and which I'll explain, which I'll show you. And of course that has certain application domain, that is not reasoning, but that is for solving advanced problems like image and speech recognition. So what about the learning capabilities? So what ANNs do is they rely on feature engineering. What is feature engineering? I'll just show you, maybe probably in this video lecture or in the next one. All right. And that feature engineering, okay, that requires manual input and pre-processing. So that's a limitation, okay, because people make mistakes, people get tired, people need a vacation, people get sick also, people do politics also. So what does deep learning do? It automates feature extraction, okay, and does not involve human intervention, and those features are extracted directly from the raw data. Here human intervention, here no human intervention. So of course that gives deep network superior performance in handling unstructured data like images, like natural language, and so on. So that makes them more powerful. And interestingly, that makes them more powerful for complex problems. So that is their application domain. Okay, now let's look at the computational requirements. So ANNs require relatively low computational resources and they can run on standard machines. You can look at the level or the complexity of the hardware here. However, for deep learning models, okay, you need GPUs, graphical processing units, or TPUs, so which are more computation intensive, requires more processing powers. Why? Because there are more larger data sets for training, and there are more and many parameters, and their deep network architecture. So this deep level architecture that requires more of everything, including the processing power, including the electric power also, energy also. So what are the practical applications? ANNs are used for simpler tasks such as basic classification and regression problems, and that requires less processing power, less energy, less data. However, deep learning powers cutting edge technologies like autonomous vehicles, facial recognition, real time language translation, and so on. So, while ANNs are useful in constrained environments, but deep learning dominates modern AI driven applications due to their advanced capabilities. Okay, so if you are interested, if you are interested in more of it, okay, if you are interested, let me clear this. If you are interested in more of this, there is more of the material. Okay, so you can read all of this, right? And then there are references at the end also. So what is deep learning? Okay, let's dive into it. So deep learning versus machine learning, okay, or deep learning versus uh, neural networks. So let's look at it. So this is what I was talking about earlier, that in a machine learning environment, okay, so we have this input and we have this human, and the human identifies the features which can be and should be or are used for classification, right? And we have this model here, and those features are fed into this model, or this model is created from those features. So this is the classification model. So we have the input, and then of course we get something which is not classified. without the human intervention. Okay, so whatever is there, it passes to to this model, and that this model classifies whether it's a car or it's not a car. That's the output. So the input and the output. Now the big difference in deep learning is that there is no feature extraction by the human. Okay, and there is no model formation. So what happens is that this input is given to this deep learning model, and this deep learning, so to say, this model basically it learns, and there's a certain process of feed backward and feed forward, which we will discuss, and the learning takes place, and those features are extracted at the pixel level, right? That is done automatically, and based upon this, neural network is trained for classification, and then whenever an unclassified image is sent, that is classified as a car or not a car, and if it is a car, then of course that could be with certain features also. All right, so let's go into some details. So what is deep learning? So we have the neural network layers. So what deep learning does, the deep learning model use multiple layers of artificial neurons, multiple hidden layers, okay? And each layer extracts increasingly abstract features from the input data, creating a hierarchy. So what it does, it enables recognition of complex patterns and helps in decision making. And it works well for tasks like image recognition, language understanding, and speech processing. So it is highly data driven. Then is feature learning. So what is feature learning? It doesn't work like the traditional machine learning. Deep learning automatically learns relevant features from raw data. So this is the raw data. It automatically learns, right, from this raw data without human intervention, and it identifies the relevant features from the raw data. And what is the advantage? The elimination of the manual feature engineering. That's gone. Okay. And so this deep learning network models discover complex patterns automatically, directly through the training on the large data sets. That is not there in machine learning, and that is not there in neural networks. So these are data driven models. So deep learning here, it relies heavily on large volumes of data, and of course that data has to be clean, and that data has to be labeled also. And this is very difficult task. This is a very difficult task. And the performance of these models, of these deep learning models, improve, okay, by statistical representations, okay, and by finding the patterns directly from the data, and they don't rely on any predefined or handcrafted features or manual intervention or manual rules and so on. They are free from them. Then is the GPU acceleration. We'll talk more about GPUs also. What are GPUs and how do they work? So training deep learning models, okay, that involves millions and billions of computations, which are handled by GPUs. So what GPUs do is that they accelerate the matrix operations and parallel processing, for which they are good at. So that makes it feasible, that processing power, that inherent architecture, to train deep neural networks, okay, within a reasonable time frame. That is very important also. Should get the answer timely. And finally, the human-like tasks. Deep learning excels at tasks traditionally requiring human intelligence, such as image classification, natural language understanding, language translation, speech recognition, and learning from ability to learn from data. Okay, and of course that can match many complex human tasks, which we'll discuss in this course. All right, let's move on to the next Q&A and the concept. As before, if you are interested in learning more about it, just click on view description of the answer. Here are the details. Here are the bullets which we covered before, and here are the references from which this data was obtained. And of course, if you want, I would suggest you follow the textbook also. All right. So how is deep learning different and similar with neural networks? Different and similar to neural networks. Now this is an interesting question. So let's look at this depth of architecture. So let's look at the similarity and let's look at the differences also. So both use layered structure, neural networks and deep learning. The difference is that deep learning models have many more hidden layers than traditional neural networks, enabling hierarchical data processing. So we see that this is an example which shows how deep learning works. Okay, let me explain this to you. So so this is bidirectional. Okay, we can move from images to the pixels or from the pixels to the images also. So from it works at the pixel level. So these pixels are combined together. This is the first layer of edges. Okay, we as humans may have very difficult task to doing this because that's not the way our brain works. So the first layer is finding the edges, okay, where the gray values are changing significantly, and of course then those second layer, those layers are form object parts, right, and then the objects themselves. So this is very different from how we perceive images, because when we look at images as humans, we look at images, we look at the if it's like facial images, we look at the eyes, the color of the eyes, the shape of the nose, the eyebrows, and everything. You see that the machine does not works that way. The reason being that the machine works at the pixel level. We humans don't work at the pixel level. Then is the feature learning. Feature learning similarity both can learn from data. Neural networks as well as deep deep learning. The difference is that deep learning automatically extracts the features. Neural networks often require manual feature engineering. So this is all automatic, does not involve human intervention. Then is the computational demand. Both need computation power, but deep learning requires significantly more resources, especially graphical processing units (GPUs). Okay, and why? Because of the depth of the network and the relationship overview. Deep learning is specialized, deeper form of neural networks focused on complex, data rich problems, hierarchical problems, which is not the domain of artificial neural networks. If you want to learn more, here are the details. I would suggest you read this. I would suggest, if you're interested, read about all this material. These are the references, they'll help you a lot. So let's talk a little bit about reinforcement learning. So, what are the elements of reinforcement learning? So, a reinforcement learning system is defined in terms of a policy. Okay, I'll tell you what is meant by policy. A reward signal. A reward signal basically something is done right, then there's a signal. Then a value function, how things are evaluated, and how the model, okay, should be of the environment. So the environment should be model based or the environment should be model free. So what is policy? So in a reinforcement learning environment, we have this environment and we have this agent, right? And agent creates actions. What is a policy? Policy defines how the agent behaves, okay? And that maps the states, this is the state in which the agent is there, into actions. And this policy guides in decision making. What is the decision making? Determining which actions to take in a certain situation. And what is the objective of this agent? The objective is to maximize the cumulative reward over the period of time. Okay, and of course, the policies can be deterministic, that is, they kind of get repeated, and they can be stochastic also, so probabilistic, right? We'll cover more of this in the subsequent part of this course. So, what is the reward signal? So, the reward signal provides feedback to the agent. This is the reward signal, provides feedback to the agent about the success of its action. This is the action. It's a scalar value, it's a number, and it is received from the environment. So, and of course, it reinforces good behavior and discourages poor actions during the learning. So, basically, uh, the objective is to optimize the reward and not to take the actions which result in uh, poor behavior, so to say. We'll talk more about it. There is a value function. The value function estimates the expected cumulative reward the agent can achieve from a given state, this state, or state action plan. Okay, it helps the agent assess the long term benefit. Remember, it's the long term benefit, it's not a short term of different actions beyond immediate reward. So this is not a greedy approach. Model of the environment. How this environment is modeled. The model predicts how the environment responds to actions. These actions, okay, by simulating the state transitions and rewards. These are the state transitions and the rewards. And what does this model allows the agent to plan ahead? Agent to plan ahead by simulating future outcomes. So basically, it is model based reinforcement learning. Try to understand. Unlike a game like football, so there is immediate decision. Immediate decision means that either a goal is scored or a goal is not scored, right or not. So if we use reinforcement learning, consider the game of chess. So the board position leads to a win, but until there is a win, okay, the board position does not uh, indicates a winner. Okay, try to understand. We'll talk more about it. Okay, so model based approach, modeling of the environment, model based approach, and model free approach. So model based approach, it uses an internal model which plan actions by simulating future events, and they are more sample efficient. Okay, but of course, if this model is not proper, is not accurate, that can be problematic. And then is the model free approach. Model free approach. So model free methods learn optimal behavior directly from the interactions with the environment without building a model. So they like focus on learning value functions or policies. Okay, therefore they are more robust, but of course they require more data also. So that's about it for this 1A part.